In this slice of physics, I'm going to talk about proportional reasoning. This is a way we can find out if a variable is increased or decreased, for instance by doubling it or tripling it. Then we can find out what happens to certain other variables when we have a formula that connects the two variables. So in this example, we're going to talk about doubling the speed, and then we're going to find out how that affects the kinetic energy. So let's suppose I have a car that is going at 20 miles per hour, and I have another car that is the same type of car that's going 40 miles per hour. So now a question I'd like to ask is, what happens to the kinetic energy of these cars? So is the kinetic energy of the kinetic energy of the faster car is probably larger, but how much larger? Is it twice as large? 3 times as large? 4 times as large? So kinetic energy of the fast car, is it 2 times, 3 times, 4 times? How much more than the small kinetic energy? So one way to do this is we could take a ratio. So we could say the kinetic energy of the fast car is 1/2 times the mass times 40 miles per hour squared divided by the kinetic energy of the slow car, which is 1/2 times the mass times 20 miles per hour squared. What is this ratio? Well, we can cancel the 1/2s because they're the same in the numerator and the denominator, and we can cancel the masses, and what's left is just this. So 40 squared is 1,600, 20 squared is 400, so that is equal to 4. So this kinetic energy ratio is 4, which means that the kinetic energy is 4 times as much in the fast car as in the slow car. Well, that was a fair amount of work. Is there something that we can do that will give us the answer faster than that? So this is what I'll call the proportional reasoning trick. So how this is going to work is I'm going to take the formula 1/2 mv squared, and I'm going to set everything in it to 1. So mass is 1, velocity is 1. And then I'm going to say what variables am I changing and how are they changing. So the 20 miles per hour is going to 40 miles per hour. So that means v is doubled. So then I'm going to take my proportional reasoning formula and I'm going to double the v. But the v is 1. So that's 1/2 times 1 times 2, so I doubled the v, squared. And this is 1/2, and this is 2. So what happened when I doubled the v was that the value changed from 1/2 to 2. So 1/2 going to 2 means it multiplied by 4. So that's telling me that the kinetic energy multiplies by 4 whenever the speed is multiplied by 2. And that's all I needed to know to solve that previous problem. So this should work whatever the speed is. If the speed is going from 100 miles an hour to 200 miles an hour, it's doubling, so the kinetic energy should be multiplied by 4. So here's another example. Suppose there's a charge over here, which is Q1, and then over here there's another charge, which is Q2, and the distance between them is, I don't know, 2 meters. So the question is, and then there's some force. So there's some force between the two charges. We'll call it F. So the question is, what happens to the force if the 2 meters become 6 meters? Well, this is tripling the distance. All we're doing here is tripling the distance, so we can use the proportional reasoning trick. So F equals K Q1 Q2 over distance squared, and we're going to make that be 1 times 1 times 1 over 1 squared equals 1. And then we're going to triple the distance. So the distance is 1, and we're going to see what happens. When we triple the 1, it becomes 3 squared, which equals 1 over 9. So it looks like the force, which was originally 1, became 1/9. So it was divided by 9. So that tells us that when the distance is tripled from 2 meters to 6 meters, then the force will be divided by 9. And that will be true no matter what the distance was and no matter what the charges are. It's just a property of this formula that always works for when the distance is tripled. Okay, let's try one more. Suppose there's a charge here and another charge here, and let's suppose that this is 4 centimeters, and that gives some force F, and I'm going to do two things. I'm going to make the 4 centimeters go to 2 centimeters, and I'm going to make the plus charge become twice as big. So what will happen to the force? Well, once again, force equals K Q1 Q2 over R squared. And we're initially going to set everything to 1, which sets the force to 1. And then we're going to try, we're cutting the distance in half, so that puts 1/2 squared in the denominator. And we're doubling one of the charges, but not the other charge. So one of the charges changes from 1 to 2. And if I do the math here, this is equal to 8. So this is saying that by doing all these changes, I am multiplying the force by 8. Now, the thing to be clear about with all these proportional reasoning problems is that this method only works in problems where you are multiplying or dividing one variable and finding out what happens to the other variables. It does not tell you an actual force in newtons. So this 8 doesn't mean 8 newtons, and the 1 doesn't mean 1 newton. These are just test values that I'm putting in to see how the formula behaves when I do certain things to it. But this does not tell me a force in newtons. And of course K isn't really 1. I'm just using that 1 as a test value to find out, because I know that the K isn't changing, so it doesn't really matter what I put for the K. But if you wanted an actual force value in newtons, then you would have to put in the correct value of K. All right.